Let's learn how to use the geometric pattern feature in Fusion 360. My name's Adam James, and be sure to like, comment, and subscribe for jumping right on in. So the geometric pattern feature is only included within the product design extension within Fusion 360. It costs $595 a year or 4 cloud credits a day for daily usage. I think I said 5 cloud credits last time, so there's a little correction there. Similar to the last feature that I reviewed within this product design extension, the volumetric lattice feature, this geometric pattern feature is still a bit underdeveloped, and I can't personally recommend the annual $595 fee to gain access to it. However, for 4 cloud credits a day, it could be an opportunity to learn how to use it into your Fusion 360 workflow. As we see here, this is actually a Google Nest Protect. So I mocked this up, and if we pull up the Google Nest Protect on Amazon, you can kind of see that it has a similar geometric patterning feature on the top of this smoke detector grill. I thought this was super neat and a good representation or similar example to how we might be able to actually implement that patterning technique into our workflow. If we minimize this, we'll see that I was kind of able to do a similar design, and you'll notice that this is actually on a curved surface that then propagates out as well as increases the diameter of the holes as it goes towards the edges of that device. As we get deeper into this tutorial, I will go into some of the limitations within the geometric patterning feature though. So in the next example, I tried to incorporate the geometric patterning feature on a very organic shape, as you can see here. It actually did a really good job at radially spreading these out from a very small diameter hole to a larger diameter towards the edges without having much complications at how organic this geometry is. This looks pretty cool, and I think it's a good representation of how the geometric patterning feature actually propagates along very complex surfaces. So in our first tutorial at a basic or a lower level, we'll start to understand how you can use the geometric patterning to create some extrusions on a disc. Then we'll go over how you can use it to create embosses and cut into a plate. And then we'll also understand how we can do it in a rectangular format. And then what's kind of neat is you can also create your own custom shape, similar to kind of that volumetric latticing video that I just recently created. You can create your own custom shape here shown on the right, and then pattern that with the geometric patterning feature. At the top right here, let's just click New Design. And we'll create a new sketch, do C for circle, select the origin, and D for dimension, we'll just give this a diameter of 40. Hit enter, hit escape, finish the sketch, and we'll extrude this, maybe 3 millimeters should be just fine. And this will be our kind of low-level understanding of how to actually use the geometric patterning feature. So we'll go into create. We'll go down to pattern, and then at the very bottom here, we see geometric pattern, and we'll just left click on that. So right away, it says it's already selected our face, and it's already selected a sphere as the geometry type. So when we see object type here, this is actually the object that it's going to pattern within this geometric pattern feature. You can also select cylinder, you can select box, and those are the only 3 shapes that you can choose. And then it kind of relies on you to create a custom object for that selected face. So let's just keep it at sphere for now. We see size limit 1 and size limit 2. So this is, and I actually really dislike, I was watching another tutorial on YouTube as well, who's having a very similar issue, but when you go normal to the surface, you can't actually see what's being patterned. So you kind of have to shift middle click at an angle to understand how big or where the geometry is actually being patterned on your surface, which is kind of maybe a bug, but that should really be fixed. So when we look at size limit 0.1 millimeters is basically the smallest size of the diameter of our object. So for the sphere, it'd be 0.1 millimeters. And then size limit 2 is going to be the largest diameter that we go up to or extend out to within the geometric pattern. So say for example, I change this to 1 millimeter, it changes the outer diameter of our spheres in accordance to that size limit 1. The spread, I think this is actually a cool tool. It basically is a weighted scale. So say for example, you want most of your size limits to be on the larger side, say closer to 1, then you would bring the spread up to like 0.5. And if you bring it up to 1 exactly, all of them are going to be size limit 2. So they're all going to be 1 millimeter, and it's just going to pattern the same 1 millimeter size. And similarly, if we drag this all the way down to, say, -1, oh, come on, all the way down, they're all going to represent that 0.1 millimeters, which you can't even see, actually. So let's spread this up. And if you say have it at 0.2 or -0.5, for example, then it's going to weight the majority closer to your smaller diameter sphere. Let's keep that at 0 to have it evenly distributed. And then you can select your distribution type. So for example, right now we have it set to circular. You can also have it set to hexagonal. And it's really hard to see, apologize. Okay, there we go. So you can kind of see the hexagons propagating on that surface there. You could set it to triangular, which really doesn't do a great job on this disc. And then you could do rectangular as well. There's also radial, and those are the 5 distribution types that you can select from. But let's just keep it at circular for now. You can define the radial distance. So if we change this to 2, for example, this is going to be the distance in between your objects as you go out towards the perimeter of, say, your disk here. So if I bring this radial distance up to 10, it will decrease, oops, it didn't, to 10, it will decrease the number, and you'll see you only see 1 because the disk isn't large enough to actually incorporate those. So let's bring this down to maybe 5. So now we've got 2, bring this down to 3, and so forth. And then the distance is going to be the distance in between the objects. So you can think of it as maybe like a wall thickness, for example. Let's bring this down to maybe 2, for example, and you can see how close together they are now. The U and V alignment, those are basically where you want this aligned in accordance to the surface itself. So say, for example, you want your geometry propagating from one side of the surface, then you would have it be aligned left or aligned right. You'll see this flip, and then your V alignment flipped as well. I usually just do center. It's easier to understand kind of the patterning, and because you can't actually select, say, a surface to align that to, I'm not necessarily sure why you would want to align left or align right, unless it's just for visual representation, which is why I've kind of referred to this geometric patterning as more of a geometric texturing. So next we have this clear perimeter checkbox. So if we select this checkbox, we get presented with this perimeter offset variable. This is basically the offset from the edge of the geometry that you're working with. So say you want like a 3 millimeter offset from the edge of your perimeter, that's just going to pull this in from the edge. Say you have like a curvature or a fillet on the outside and you want enough wall thickness or material there, that's when you would use this, but we can just keep it off for now. And then the last selection in this window is going to be your operations. So you can either join, cut, intersect, or create a new body from these objects. So let's just do cut for now and then select OK. So what you'll see is it's created a geometric pattern with the objects and the distances that we defined in a circular geometry. Great, now let's go to new design again. We'll do this on a plate. We'll just select create a sketch, left click on this top plane. We'll go to rectangle, center rectangle, select the origin, D for dimension, just do 50 and 50 on the edge here. Hitting escape and then finishing our sketch. Just extrude this, E for extrude 3 millimeters and hit enter. And then we'll go up to create pattern, geometric pattern, and we will select the face we want to pattern. For this example, maybe let's just do a box. And you can see here in the geometric pattern window that under distribution type, it's still patterning it in a circular manner. So you can, again, select this in accordance to your design. For this example, we can just select rectangular pattern. And what you'll see here is that some of these are actually extending over and beyond the size of our face here. So what we can do, instead of increment, I'm actually going to go to extent. And what extent allows us to do is give a quantity selection for the U and V direction. And I did want to make a comment about the U and V. I think it should have been X and Y, or at least if they're going to label it U and V direction, they need to call it out somewhere on the axis because it's really hard to keep track of that, quite honestly. So we can make this, let's say 20. So our U direction is from left to right is X, and then V is 20 as well. So we've increased the quantity. And then what we want to do is actually select clear perimeter this time. And you'll notice that it got rid of all those boxes that were overextending the bounds of our surface. So if we bring this down to maybe 1 millimeter and hit enter, we've got a 1 millimeter clearance from the edge, and we've got a geometric pattern in these kind of box shapes all the way across our plate. We'll do one more simplistic example using, say, a triangle. Let's just do a rough sketch. Hit escape, finish sketch, and then we can E for extrude 3 millimeters, hit enter and escape. And then let's select our face and go down to pattern, geometric pattern, and it's still on rectangle for distribution type. And we could go to triangular, and it does a pretty good job at identifying realistic center bounds of where it's going to start. But I think that's also a limitation of this geometric patterning feature is you can't actually select where you want it to really start and end. And that's a big deal because if you really want it to pattern, if you've seen kind of my patterning the honeycomb example and my other Fusion 360 tutorials, you really have a lot of leverage in defining the extent and where that those hexagons are actually placed. Not so much when using this product design extension, you know, the geometric pattern, while paying $595 a year. So not great in that sense. Let's change some of our limits here. Let's go to maybe 0.2 is the lower bound, and we could try 2.5 as the upper. And let's hit tab. Let's make it a little bigger, 3.5, hit tab. Okay, so you can kind of see what it's doing now. Let's change this maybe to a cylinder, and then we could go down here to operation, and we could just do joins. This is going to create a feature, and then we'll select OK. And you can see exactly what it did. So it creates this kind of cool texturing pattern along the face of our surface. Now let's jump into the Nest Protect. One of the biggest limitations that I think I faced when actually creating this geometric pattern is the inability to actually extrude this all the way through the wall thickness of this top part. So if I go in here to bodies and I hide maybe body, what is this, 737? Okay. You'll notice that these are not actually going all the way through. And if we look at the Nest Protect, I've actually torn one of these down before, and what you'll notice is these holes actually go all the way through the plastic housing, and then there's a sheet underneath. But you can't actually do that within this feature, especially if you're going along a curvature. Let me go into the example here, right-click on Geometric Pattern, and do Edit Feature. And I do want to mention that anytime you edit one of these more complex geometric patterns, especially along a curvature, which is not just a flat face, it lags Fusion 360 extremely badly and almost creates a work environment that is not usable. So just be aware if geometric patterning is one of the main reasons that you want to purchase this $595 product design extension within Fusion, I'd be very hesitant on making that decision. So what you'll see is we have a cylinder, and I used just this sphere to get myself this kind of cool texture from a size limit of 0.1 to 2.0. So we're not going to adjust these parameters per se. But what you'll notice is even if I go to sphere, you'd think that there'd be an extrusion depth that you can enter, but that's not the case. It only gives you the size limits, size limit 1 and size limit 2, and it will only extrude into the surface if size limit 1 is big enough to cut through the plastic body. So you can see how long that took just to adjust from sphere to cylinder. And if let's pull this guy, you would think maybe it would increase the extension, but what it's actually doing is increasing one of the size limits. So let's see what this goes to. So as you can see, by just dragging that, it increased the size limit 1 to 5. Now, of course, this won't work because size limit 1 is now larger than size limit 2. We've got a lot of intersecting pattern profiles here now, so let's just bring this back to 0.2. This is kind of a bummer because it really doesn't represent what we're trying to achieve in this Nest Protect housing. Let's just click cancel here. And what I do want to show is that it actually does give you an opportunity to create a render, which I think is pretty neat because the volumetric lattice just for some reason disappears whenever you enter the rendering environment. This I think is pretty cool if you have, say, a texture that you want, say, shown off on your new product design. It gives you the opportunity to render it. With that being said, you can also create an STL and a step file, and all of these features will be included in there. Now let's go ahead and go up to New Design at the top right here, and we'll create an organic shape. We'll go into our Surface tab, and we will create a form, and we'll create a cylinder. Let's left-click this top plane here, and I will left-click in the center, and I'll give this a dimension of maybe 40, and then left-click on OK. If you're new to surfaces, that's okay. We'll go into Edit Form. Just left-click on this point, and you can drag it out to kind of create this organic protrusion. Do the same thing on this one. And just drag this. And then we could maybe do the same thing on this side, but drag it inwards. And then we'll do maybe one more right here, and we'll drag it super far out and maybe up. We'll select OK. So we've got this super funky looking shape. Let's finish the form at the top here, and then we could go up to Patch. We'll select this top ring and then select OK. You'll see it presents this surface. And then we'll do the same thing on the bottom, and then we'll select OK. Now these are inside out. You can tell because the yellow surface is facing us. We can go into Modify and then select Reverse Normal. Select this surface. Shift middle click and then select this bottom surface as well. And then now you can see we're all set to go. Now let's stitch these together. Left click, left click, left click OK. And then let's left click, stitch again, our main body and the bottom, and then select OK. Great, now we've got a solid body that we can go back into our solid workspace at the top here. Let's create a new geometric pattern. So create pattern, geometric pattern, and we can just select the face that we're interested in. And you can actually see it does a pretty good job at following this organic shape geometry that we just created. So let's mess around in here a little bit. We can create a sphere. Maybe let's make the max like 6. Let's see what that looks like. And the minimum maybe 0.1. It says it's at triangular as the distribution type. Let's change that to rectangular maybe. Quantity, maybe let's do 20. And let's do 20 again. You can see how slow Fusion is working right now. It looks like the max size limit, let's bring that down a little bit to 4, hit tab. You can kind of see that you want to bring your size limit 2 down a little bit if these geometries are conflicting with each other. Again, we want it to maybe be down even more. Let's go to 2. Okay. Looks pretty good. It's really hard to see where it's even bringing our size limit 1 from. It almost looks like it's patterning it from the back to the front. which really gives us no opportunity to define the start or the end or specify where we do or don't want this patterning to take place. So if you want some random texturing, I guess, to your part, then maybe this feature is for you. And let's select OK just to see what we've really created. And this is kind of what we've created. It almost looks like octopus tentacle like bumps coming off from this super organic shape. So not sure why you would want to do this. And again, just an example of how it can conform to an organic shape. Let's finish off this tutorial with understanding how you can create a custom shape to then use in the geometric patterning feature. We'll just go up here to circle, create a circle at a diameter of 40 millimeters, hit enter and escape, and then finish the sketch. Select the sketch profile, maybe give it 3 millimeters again. And then we're going to create a different sketch. So sketch on the top plane again, and just with this fit point spline or any geometry that you would like, just click and close a loop and finish sketch. Great. And this is actually really big, but I guess we'll see how the geometric patterning feature reacts when we have this super large geometry when we're trying to pattern on a small size. So what you do need to do is left click on the sketch profile, and it has to be a solid body in order to include it as a geometric pattern. So we just give it a thickness of 10 maybe and select OK. All right, so let's select the disk face here. We'll go to create, go into pattern, geometric pattern. And then when we look at object type here, we have this custom selection. And the custom object we'd like to select is this spline that we just extruded. So we will select that. And then the perpendicular direction. And for the perpendicular direction, you can select the y-axis in the origin. Great. And let's go down. Oh gosh. So the size limit 1 has brought it to 93 millimeters, which is larger than the disk that we're trying to even pattern on. So let's bring this down to maybe 0.2, and let's bring this to 4. So it can't do 0.2 for some reason. Okay, 0.2 is too small, but it actually did a pretty good job at now patterning this new sketch profile extrusion that we just created from a spline. And you can see we could select our distribution types. I'm just going to leave it at rectangular for now. And maybe let's just do align left. See how that looks. And instead of join, I'm just going to go to cut and select OK. And there we go. All right, that sums up this tutorial. Again, it's not really the geometric patterning feature that I was expecting. It's again more of a geometric texturing feature, and it doesn't allow you to extrude through solid bodies all the way through. Fun to play around with, but I can't really recommend it as an engineering tool. If you guys found any sort of value in this content, be sure to hit that like button, subscribe, and I'll catch you in the next one. Thanks.